Greetings, ladies and gentlemen. Welcome to your lesson about special right triangles. I don't know if you guys remember this thing, but we just had a whole unit about trigonometry. All right, you got sine, cosine, tangent. You can use it to find unknown side lengths. Well, we are going to continue to work with trig a little bit for a few lessons here. And these next things are going to focus on special right triangles and what knowing about special right triangles can teach you about sine and cosine and tangent of all sorts of angles, even ones that are bigger than 90 degrees. Yeah, and we'll get there eventually. But first, let's start here with the basics. What the basic special right triangles are. The first one we're going to talk about is the 45-45-90 triangle. And the reason it's called that is because the angles are 45 degrees, and 90 degrees. And the thing that's the two properties that are really helpful with these triangles is that whatever one of your legs is, the other leg has to be the exact same. So if my leg down here happens to be like 10, this leg over here is also going to be 10. So that's a handy thing about all 45-45-90 triangles is the legs have to be the same. And then the other special property is that the hypotenuse is the square root of 2 times whatever the leg length is. And so this hypotenuse length here, if the leg was 10, is going to be 10 square root 2, or 10 times the square root of 2. And you can do this for other numbers, like this. Our leg here could be 7, and then this side here would be 7, and this side would be 7 square root 2. If your leg was a billion, this would be a billion, this would be a billion, and this would be a billion times the square root of 2. And that's just going to be the same for all 45-45-90 triangles, regardless of initial size. They will have those relationships with each other. The other special right triangle is a 30-60-90 triangle, and it's called that because the angles are 30 degrees, 60 degrees, and 90 degrees. And the relationship that these sides have is a little bit more complicated than the 45-45-90, but here's how it works. So the smallest size is going to be related to the other two sides in this manner. The hypotenuse is always going to be double whatever the smallest side is. So if my smallest side here was 5, the hypotenuse would be 2 times 5, which would be 10. And if my smallest side was 3, then the hypotenuse would be 6. If my smallest side was 11, the hypotenuse would be 22, right? Double whatever the smallest side is. Well, the other leg here is also related to your smallest side. It's going to be your smallest side times the square root of 3. So if my smallest side here was 7, then the other leg would be 7 times the square root of 3, or 7 root 3. If my smallest side was 25, then my other leg would be 25 square root 3. And that's going to be true for all 30, 60, 90 triangles. Regardless of whatever this small length is, it'll have these relationships with the other sides. And so, now that you know those things, we're going to look at a few examples from your assignment. Some of them are going to be incredibly easy, and then some of them have a bit more involved as you get towards the back side. There. Let's start at the beginning here. Number 1, you're supposed to, in all of these, you're supposed to find all the missing side lengths, and you want you to leave all your answers in radical form, in the simplest radical form. I do not want decimal answers on this, so no decimals on this. This is all going to be just square root and fractions and things like that. No decimals. So look at this. I need to get both of these lengths. And we're not going to use trig this time. We're not going to use like sine, cosine, tangent. We're just going to use those properties we were looking at. Well, this is a 45-degree angle, which means this is also going to be 45. And this is going to be a 45-45-90 triangle. And what that means is the two legs are going to be the same length. And then the hypotenuse is the whatever that length is times by the square root of 2. And so I can start filling these in pretty quickly. Since this is 4, this is also going to be 4. So y is 4. Piece of cake. And then I have my hypotenuse here, x. Well, x is going to be this side length times by the square root of 2. So it's 4 times square root of 2, which is just going to be 4 root 2. Problem over. Again, I don't want you to get the decimal approximation. Just write out. And that's as simplified as it gets. So it's done. Let's jump to another one. Number 3 here. So this one, I see I have a 60-degree angle here. And that means this one's going to be 30. And that also tells me that this is going to be my smallest side here. Well, if you go back to our information about 30, 60, 90, the other leg, so if your hypotenuse is double the shortest side, and the other side is going to be the square root of 3 times the shortest side. Well, let's look at this one that we have. Well, it looks like I have the hypotenuse, and I don't have my smallest side, and I don't have the other leg. And so I can go from here to here. You just have to remember that this side here is double the shortest side, and the shortest side is B. So if I want to get B, I know that my hypotenuse here is double the shortest side. So I can just solve my little equation here, and I'll get B is 2 root 2. So I can put that down here. This is 2 times the square root of 2. And that's because the hypotenuse is always double the shortest length. So if I cut this in half, I'll get my shortest length here. And now that I have my shortest length, I can actually get this one. And that's because the other leg is the square root of 3 times the shortest side. So whatever the short side is, let's just call it triangle, times square root of 3 is this guy here. Well, I know my shortest side length now. It's 2 root 2, so I can put that there. I'm erasing too many things. So A is going to equal shortest side length times y to the square root of 3, which is, if you've forgotten, the front things times together. So 2 doesn't have anything to times with, so it's just 2. And then the radical numbers times together, so you get square root of 3. Sorry, not square root of 6. Square root of 6. My bad. That's a bad 6. And so we got our other side length here. A is going to be 2 square root of 6. So I got my short length. I got my other leg there. And that's all from starting from our hypotenuse. So that's how your 30, 60, 90s can be related to each other. Sometimes it's kind of a puzzle. Sometimes you don't start with your shortest side length, just like this one, and you have to figure it out. But luckily, it is related to its neighboring sides in that way. So now we've done a couple of these. Let's go to one on the back that'll kind of test your ability to deal with these. We're actually going to look at number 9. So number 9, you need to get this length. Well, this length is the hypotenuse of a 45, 45, 90 triangle. But we don't have either of these lengths. And so we can't get the hypotenuse if we don't know either of the side lengths. But luckily, this length up here is symmetrical. Well, not symmetrical. It has a reflexive property, saying that that side length is also part of this upper triangle. And we can use this upper triangle to get this length down here and use that length to then get our hypotenuse. And so we're going to just focus on the top triangle real quick, trying to get this small side length. Well, I look at my triangle here. I see there's a 60-degree angle, which means up here is going to be 30. And that lets me know this is the smallest side of a 30, 60, 90 triangle. And if you remember, the second leg is equal to whatever the small side is. Let's just call it triangle again. Small side times the square root of 3. Well, that lets me know that I got an equation of 10 equals triangle times the square root of 3. Triangle being this length here. Well, I can divide that by square root of 3. Divide by square root of 3. That was a bad triangle. Is 10 over root 3. But I don't want a square root on the bottom, so I'm going to times top and bottom by square root of 3. Remember, trying to simplify the radical. So my short side, it turns into 10 root 3 over 3. And these don't simplify. They don't cancel at all, so we'll just leave it like that. So that's my small length up here. Well, now that I have my small length, I can get the hypotenuse. So I'm going to switch colors here. My hypotenuse is the shortest side there. Let's call it triangle again. But it's times the square root of 2 to get the hypotenuse of a 45, 45, 90 triangle. And so I can take this number and plug it in there. It's going to be x. So x is 10 root 3 over 3 times by square root of 2. The square root of 2 doesn't have a denominator, so the denominator is 1. That means my denominator is going to stay 3 here. Times those together. Then you have to times these together. It becomes 10 square root of 6. Remember, if you had two radicals, you multiply the inside numbers. So now I got this, and you have to think, can this be simplified? Well, sometimes people think you can cancel these out a little bit, but you can't because the 6 is inside the square root. Only things outside can cancel and things inside can cancel, but you can't cross that line. And so this is actually our simplified answer. 10 square root of 6 over 3. So yeah, the back's got, kind of some challenges there, but it's that same idea, just relating the sides to each other using these properties we looked at the beginning. On a 45, 45, 90, the legs are the same, and the hypotenuse is the square root of 2 times the leg. And on a 30, 60, 90, the hypotenuse is double the smallest length, and the other side is the square root of 3 times the shortest length. And when you know those properties, you can get all those sides. So good luck, practice lots. You'll want to know it for tomorrow and the day after and the day after.